So today what we're going to work on are applications of matrices and determinants. So I would like you to put me on pause and try this and then come back and check your answer. All right, so it says to find the area of the triangle whose vertices are 2, 8, 6, 2, and negative 2, 2. So the first thing you want to do is to plot the points. So we have negative 2, 8. And 6, 2, and negative 2, 2. Okay, so remember the area of a triangle is 1/2 the base times the height. So we need to find the base and the height. So what you could do is just count the boxes. So the base, count the boxes, is 8, and count the height, that would be up and down, that is 6. So your area, which is 1/2 the base times the height, is 1/2 8 times 6. So half of 8 is 4 times 6 would be 24 square units. Okay, so, well, this is nice if your vertices are given and they are running along the parts of the graph that contain the lines. Well, what if you have a triangle that looks like this and it doesn't stay on the lines of your graph? Well, then how do you find the area of this? And that's what we would use the area of a triangle using matrices and the determinant. All right, so how would you find the area if you are given vertices? All right, so I have my vertices, my 3 points. So it's x sub 1, y sub 1, x sub 2, y sub 2, x sub 3, y sub 3. So what I do is to find the area, it's plus minus 1/2. And then remember, the bars doesn't mean absolute value. It means the determinant. And we set up this matrix here. All right, so with your points down the first 2 columns, so it's x1, y1, x2, y2, x3, y3. And then in the last column is all ones. All right, so now why is it plus minus? Well, it's plus minus because we have to figure out what will give us a positive area. So you use the sign that will give a positive area. Okay, and remember the bars, it's not absolute value, that means determinant. So what this means to do is it's 1 plus minus 1/2 the determinant. Okay, so we're going to actually do this triangle up here, up top. We're going to do this triangle using this method here. So we know that the area should come out to be 24. So we're going to try that. Okay, so we have find the area of the triangle whose vertices are negative 2, 8, 6, 2, and negative 2, 2. So its area is equal to plus minus 1/2 the determinant. So that's going to be negative 2, 8, 6, 2, negative 2, 2, and then 1's down the last column. So remember, to find the determinant, we have to find our minors and our cofactors. So I'm going to use my constant is going to be row 1. I'm going to keep constant. So I want to do minor 1, 1. So minor 1, 1, remember we take this out, the 1, 1. So I do my determinant for my 2 by 2 matrix. So that's 2 times 1, which is 2, minus 2 times 1, which is 2. So that's 2 minus 2, which is 0. So my cofactor of 1, 1 is going to be a positive. Remember, because 1 plus 1 is 2. So negative 1 squared is going to be positive. Times 0 is just going to be 0. Okay, so now I want to do minor 1, 2. So minus 1, 2 would take out those, and I'm left with 6, 1, negative 2, 1. So that's going to be 6 times 1 is 6, minus 2 times negative 1 is negative 2, which is going to give me 8. So my cofactor is negative 1 to the third power is going to be negative times 8, which is negative 8. And then I need to do minor 1, 3. So I'm going to squeeze that in there, sorry. Okay, so minor 1, 3, I would take out row 1 and column 3. So it would be 6 times 2 is 12, minus negative 2 times 2 is negative 4. So that's 16. So my cofactor 1, 3. So it's negative 1 to the fourth power, which is positive 1, times 16, which is going to be 16. All right, so now I'm going to find my determinant. So this was my constant here. So my constants row was negative 2, 8, and 1. So my determinant is going to be negative 2 times my cofactor, which is 0, plus 8 times my cofactor, which is negative 8, plus 1 times my cofactor, which is 16. And that comes out to be, let's see, 0 minus 64 plus 16 is negative 48. So my area is going to be 1/2, plus minus my 1/2. So which one would I want to use? If my determinant is negative 48 and my area has to be positive, then I have to use negative 1/2. So it's going to be negative 1/2 of negative 48, which gives me 24. Okay, so let's try another one. Okay, find the area of a triangle whose vertices are 1, 0, 2, 2, and 4, 3. So the area of the triangle is plus minus 1/2. My determinant, which is going to be 1, 0, 1, 2, 2, 1, 4, 3, 1. That's the matrix I'm going to use. All right, so we're going to use M, my minor 1, 1. So that's going to be 2 minus 3 is negative 1. So my cofactor 1, 1 is going to be positive 1 times negative 1, which is negative 1. And then I'm going to do my minor 1, 2. So minor 1, 2 is going to be 2 minus 4, which is negative 2. My cofactor 1, 2 is going to be negative 1 times negative 2, which is 2. And then my minor 1, 3 is going to be 6 minus 8 equals negative 2. And my cofactor 1, 3 is going to be positive 1 times negative 2, which is going to be negative 2. So my determinant is going to be 1 times negative 1 plus 0 times 2 plus 1 times negative 2. So that's negative 1 plus 0 minus 2, which is equal to negative 3. So my area is going to be equal to, so I need negative 1/2 to make it positive. So it's going to be negative 1/2 times negative 3, which is positive 3/2. That would be the area. So it's 3/2 square units. Okay, so let's flip it over and we'll try a couple of other problems. All right, so collinear points. Collinear points are 3 points that fall on the same line. They cannot form a triangle. So since the points cannot form a triangle, then the determinant must be equal to 0. So this says here, determine if the points are collinear. So remember, if they're collinear, the determinant is equal to 0. All right, so let's find the determinant. So it's 0, 4, 1, 2, 6, 1, negative 3, 1, 0. 1, sorry. Okay, so we're going to start with minor 1, 1. So minor 1, 1 would be 6 minus 1, which is 5, Cofactor 1, 1 is going to be positive 1 times 5, which is 5. Minor 1, 2. Minor 1, 2 is going to be 2 minus negative 3, which is positive 5. So cofactor 1, 2 is going to be negative 1 times 5, which is negative 5. And then we need minor 1, 3. So minor 1, 3 is going to be 2 minus negative 18, which is 20. So my cofactor 1, 3 is going to be positive 1 times 20, which is 20. Okay, so now my determinant. So I used a constant row 1. So it's going to be 4 times, it'll be 0 times 5 plus 4 times negative 5 plus 1 times 20. So this is 0 minus 20 plus 20, which is equal to 0. So therefore, the points are not collinear because the determinant does not equal 0. Okay, so we have one other type of problem to go over. Okay, so that would be finding an unknown. So find x such that the triangle with the given vertices has an area of 6. So you're just working backwards with the determinant and the area. So my area has to be equal to 6. So 6 is equal to 1 plus minus 1/2 the determinant, which is going to be 271, 311, 0x1. Okay, so I'm going to start with minor 1, 1. So minor 1, 1, so that's 1 times 1 is 1, minus x times 1, which is x. So it's 1 minus x. So my cofactor 1, 1 is going to be positive, right, because negative 1 to the second power is positive 1, times 1 minus x, which is just going to be 1 minus x. All right, minor 1, 2. So minor 1, 2 is going to be 3 minus 0, which is 3. So my cofactor 1, 2 is going to be negative 1 to the third power is negative 1 times 3, which is negative 3. And my minor 1, 3. So minor 1, 3 is going to be 3 times x is 3x minus 0 times 1, which is 0. So that's just 3x. So my cofactor 1, 3, so it's negative 1 to the fourth power is positive 1 times 3x, which is just 3x. Okay, so my determinant is going to be equal to 2 times 1 minus x plus 7 times negative 3 plus 1 times 3x. So my determinant is, I'm distributing the 2. So it's 2 minus 2x minus 21 plus 3x combined like terms. This is my determinant. Negative 2x plus 3x is x, and 2 minus 21 is negative 19. That's my determinant. So now remember, my area is 1/2 plus minus, so it's my area, which is 6, equals plus minus 1/2 my determinant, which is x minus 19. So now I'm going to split this up. So 6 is equal to 1/2, that's the positive 1/2, x minus 19. Or x is equal to negative 1/2 times x minus 19. Okay, so to make this nice, I'm going to get rid of the half by multiplying both sides by 2. So that's 12 is equal to x minus 19. Add 19, and we get x is equal to 31. Or multiply both sides by negative 2. So I get negative 12 is equal to x minus 19. Add 19, and I get x is equal to positive 7. So x could be two different things to get me 6 as an answer, 7 or 31. Okay, so that's it, and we'll practice in class tomorrow. Have a good night.